Okay, I am definitely in the avoidance mode here, but I want to try to go slowly here and look for kind of the most direct method that I can think of at this point in just getting people to learn some rote information regarding, and this is what we'll be talking about here, regarding the key values on the unit circle. Key values on the unit circle. And essentially the key values on the unit circle, it turns out, if you think about going to the very, very basis of it, it is the value if the angle and the angle in degrees and angle in radians, right? And what is the value of the x and of the y? And if we start here, knowing that the world shifts or rotates 15 degrees per hour, which is the same as pi over 12 radians per hour, we can realize that the key angles are 0, 15, 30, and 45. The radians, IANS, are 0, pi over 12, pi over 6, and then pi over 4. The x values, you're going to realize the x is 1 and 0, and you have a number pattern that exists here, which you're going to see there's another way to traditionally is taught, but then there's a number pattern that exists here as well. So we're going to put that there, and we're going to come to that in a second. You'll see that the number pattern typically taught on the unit circle is for 30, 45, and 60 degrees. So that's where this can get a little bit odd. I'm going to put one thing that we understand is that for this number pattern, everything is over 2. And eventually, I think it's easy to realize that there's a 1, double 2, 3, and then it works this way. 1, double 2, 3. Square root of 1 is 1, square root of 2, and the square root of 3. And later on, you're going to see this makes sense pictorially. This is old hat, and there's better ways to do this, but learning this is just the first sliver. I'll try to draw it up here, badly if you would, to realize that once you know the first 1/8 of a circle here, it's going to let you go ahead and do something called mirroring it all the way around the circle. So we now get to the number pattern which I have not seen taught, and that is this. The x is 2, 4, 6, and the y is 2, 4, 6, and the square roots go everywhere on top with a plus here and a minus there. So to review, even though there are other ways to go about learning, what we really get away from if we don't teach that 15 degrees, and I presume it wasn't taught because it wasn't convenient, we get away from learning that one of the key bases of use of angles is a 1-hour rotation, which is 1/24 of the way around a circle that has a full rotation of 2 pi. And so if we then go to the key angles being 0, 15, 30, and 45, knowing that the 15 is pi over 12 because the full angle is 2 pi for a full rotation, going to twice that is pi over 6, and then basically, very quickly, we do start to want to know that we have 90 here, and the 90 is pi over 2, which makes 45 pi over 4. Then recognizing the number pattern that is taught into 30 and 45 is everything's over 2. It's 1, double 2, 3. In this way, if you've got square roots on everything on top, and the square root of 1 is 1, of course. And then most importantly, realizing that in fact there is another number pattern that emerges, which is 2, 4, 6. 2, 4, 6 with square roots, a positive on one side and a negative on the other. Now these come from some of the most basic ends of the history of trig, etc., things called the half angle theorem and the double angle theorem. But in this, you quickly then learn to adapt and adept what also is known later on in terms of the decimals when you get into engineering, and you just, instead of talking about the x, you talk about the cosine and the sine, and then you of course have 0, I'll use 15, I'll use 30, and I'll use 45, that you know the cosine of 0 is 1, the sine of 0 is 0. 30 degrees, the cosine is the x value, which is 0.866, and the sine is 0.5. At 45, it's 0.707, 0.707. And you go back to here, and by the time you work all this out, you get 0.9659, and then 0.2588. You do this even though you know the definition of tangent is sine over cosine. You can go over here and you can learn to approximate. All of a sudden you know that the 30 degrees is 1 over the square root of 3. This is 1, the tangent of 0 is 0, and the tangent of this is pretty close to the small angle of pi over 12. It's not exact, of course. You'd take 0.2588 divided by 0.9659, but when you do that, you'll end up with something like pi over 12. So this companion video does a couple, or as we look at some of the companion video, it gets you to learn in one pattern just that first slice, and that's fundamentally different than learning what typically is done, and I'll finish with that. Actually use the eraser thing for here for once. I don't erase much, I'm going to erase. And I'll take you back to what's typically taught when they teach the unit circle, and what they typically ignore, of course, is 15 degrees, which once again is the foundation for 1 hour's time when you look up at the sky as the world, at least for today, continues to revolve about its axis. So if you have a circle here, here's how it's best taught if you're not trying to kind of get the first just 15 degrees. You start here, you consider that a unit circle, and smartly you learn to divide this by a half and this by a half. That gets you what becomes a 60-degree angle, a 45-degree angle, and a 30-degree angle. You open parentheses 3 times. You say over 2, over 2, over 2, over 2, over 2, over 2. You see that this is halfway along the x. 1, 2, 3, 1, 2, 3. You take the square root of 1, which is 1. You take the square root of 2, the square root of 3. The square root of 1 is 1. The square root of 2 and the square root of 3. But in that, you lose the fact that basically maybe you don't lose it. You get an inkling that basically the most key part of this unit circle is to learn the first 45-degree or pi over 4 slice. So that is not necessarily the best early way to learn, but if you learn it this way quickly, very quickly you can start to know that in fact if you want the sine of 75 degrees, you take the cosine of 15 degrees, or things like that. Thanks for listening.